Hey everyone, this is my first time, so please forgive me if I make any mistakes. Today we are gonna take a look at reverse engineering a little bit. I have made a few um, binaries that we can exploit. The source will obviously contain the source code, and here are a couple of one of the UD binary is a binary I found on a CTF, and the encrypt one is I made myself. As you can see, they are both ELF binaries and they are not stripped. So first let's try to get into a little decompiler. So I'm going to be using ghidra. Ghidra is a Java based decompiler which takes a binary and extracts the instructions and then compiles it into a C program. Since I've written this in C itself, it would be very similar. So let's try including this first. Let's just set everything as default for now. And this is a debugger, and I accidentally opened it without opening the file. But first I generally prefer dark mode on most things, so I am gonna change the settings a little bit, but I would recommend you do this after you've gotten a little bit used to the controls, because when you invert the colors, these buttons here don't change. So the visibility may be a little lower, but it should be fine for me. I've used it a couple of times and I have to restart it for the effects, for the changes to take effect. As you can see, it's in basically dark mode here, and let's try opening up the binary I made into the compiler itself, and here it would ask me to whether to analyze it or not. Always say yes, and I would go with select all, the leftmost button right here, and apply and then analyze. It will take a little bit of time, just wait for the, okay, it already finished, but you would wait for the loading bar here to get done. So basically, when a binary is created, these are the headers. This is the entire binary in hex format, and here on the right side we see the data structure, the commands, or you can say the initial stuff are the headers. There's not much program here. These are still the initial binaries used to set it up. These are the libraries and functions that are used in the binary itself, and these are pointers to those. And the program, these are the individual functions like printf, and what the assembly code would be for that function. And let's see if we can, okay, so functions are all listed here, and like the exports I think would contain imports, libc external, yeah. So these are the functions that are used, like the external functions that are loaded from header files, which are installed by default in the compiler, the C compiler. These are the functions. The ones that start with underscore are generally not that important because they sort of exist everywhere. Since this is not a stripped one, the entry point function would be main. Let's take a look at the code. It decompiled for us. So there are a lot of undefined variables. So like if you know the basics of programming, these especially C, this is the data type and this is the variable name. This is how you define variable types. Most of them are undefined. There's bytes and int and unsigned int. There's a file that's been loaded and another undefined and an int. So these are a few variables that are predefined. Each of them has a hex value. If it is preceded by 0x, it is hex, and as you can see when I hover my pointer over it, it would give me the hex decimal and the char value as well. So these are just variables for now. We'll get into this later. Here, so the first function after the variable declarations being called as srand. Srand is so here, since srand is called, the initial the header included here would be random. So there is a random function being called, but since this value is constant, we would not need to go, like we could predict it what the random variables would be, since srand sort of seeds the random function, so that in like ideally it would be like time variable would be a good one, but if it is something like this, it can easily be decoded and is not at all secure. These are other two variables that I have initialized. If you look at the char array on the bottom, you can see that it's doesn't make much sense, but it's a char array for sure. And if you look at the second one, it's the same, but if you pay a little more attention, uh, if you look at it on in the reverse order, it spells out a strong P, and on the second one it spells out, if we include the P from before, it spells out password, and then there's a null character which is basically used to terminate any string in binaries. Here we are opening up a parameter 2 as read, and as you can see here, there's a parameter passed to the function itself. So we have, and it is opening a file based upon that parameter to read. So we can assume that the parameter passed here would be the file path, and it would get read here with fopen. Fopen is used to open any local file system, and the R here suggests that it is opening in read mode. There are various modes to open it. There's read, write, append. The difference between write and append is in write you just get, like, you overwrite from the base, but in append you go to the end of the file and then you start writing. So if it is not able to append, open the file, it will print unable to open file, and it will set UR is equals to this, and else the whole thing, the entire function is being called. So if this is wrong, let's assume that we call a file that doesn't exist. So it will put UR is equals to like all f's in hex, which would be -1 in decimal format, and it at the end it returns UR2. So if I click it and press L, it will let me rename it. So let's rename it to return value typo. Okay, so if I rename one variable anywhere, it will rename it throughout the program. And let's rename this as well, file point. Okay, so this will rename it as well. These is, I feel, password, so let's rename it to password 2, and let's rename this to password 1. So these two combined, I feel like, would get the password, because the strings in C programs are stored in reverse. So if we take the password 1 and look at it reverse, it spells out a strong P, and here it goes to a strong password. And then yeah, if the file is opened, it will ask us to put in a password, and then it will read the password. So let's rename this to password input, and then it does string compare with password 1, and this is check. Okay, so since we are not sure, let's just put in password check and just put in a question mark at the end. And since it's comparing it with password 1, which is here, and it is passing its address, so since we are passing it as an address, it would also, if the password input is bigger than the string present here, it would read the next string as well, going by the size of the password we enter. And if the password turns out to be true, which would return 0, and then we would start here it is getting the size. Since fseek is used to place the pointer anywhere on the file, and here we pass the file pointer which is to be used. Here we place the initial value, which can be anything in this case, because the third parameter sent here is 2, which would seek the end of the file. So since ftell is the second function called here, it would return an int, and it would tell me the size of the file. So here we can just replace it with file size, and here it is just converting it to int file. And in this line it is just going back to the base. In this for loop, this local C is incremented here, and it is being checked here, so I'm gonna rename it to loop counter. So it is being, so the loop counter is being incremented every time, and here we can see it is getting character from file pointer, one character at a time. It is converting it into, it is saving it into file check. So maybe that was not the only thing the variable did. here it is getting converted into the byte format, then the random is called, and then it is getting ANDed. So let's go one at a time. Byte is just to be able to AND it here and XOR it here. So let's finish this. Okay, fine, let's rename it to byte. Okay, so here is the random variable, random1, and then random1 is being ANDed by 7. So what basically happens when you AND it with 7 is it would stay below 8. So let's try and explain it here. Yeah. Let's create a new file and let's say let's remove this, and so basically a byte could be like 4 bytes when you and since you're using 7, the binary value would be this. So once you AND it, what happens is the only the matching bytes, if both bytes are 1, it would print 1. So uh, the final result would be all these would get negated to 0, and the final answer would be 3. So this is 3, this is, oh sorry, this is 3, this is 7, and this is something. This is just a random jump, you can say. So anything you put in, any random value that would be generated would get converted to below 8. It could be anywhere from 0 to 7. It is basically done so that since each character is only 1 byte long, so when you XOR it with a variable which is not present, or with a higher size like this one, the initial jump value, it would give out an error. So to remove that error, it is being ANDed with 7 so that it gives an appropriate value. So once it's been ANDed with 7, it is then being XORed. So let's rename this to encoded char. And when it is being encoded, it is being put into an in. And putchar, basically what it does is it prints it one character at a time. It is basically like put s, but instead of an entire string, it basically prints out one character at a time. So this is the basic functionality, like going through the program, that's it. So let's yeah, I mean there's also the password as well. So if the password turns out to be false, so this if ends right here, sorry, it ends right here, and return value is placed 0 only here, since it's hmm, since it's like working properly. If any error occurs like wrong password or unable to open file, it returns -1, which is a basic, like, function has gone wrong. I'm sorry for my voice, it's going down a bit. I don't really talk as much. So let's try to recreate this. So the most simple way I can think of is just to copy paste this. Select all. Okay, maybe. Okay. So it's the entire thing is pasted here, and let's just create a new, okay, not a new file, a new folder. At the end of the stream, we would look into the original source of this binary as well. Okay, so solution. So let's just save this into solution. Base.c. So a few things we do need to change, like this undefined. It cannot be undefined because like that's the ghidra trying to decompile it, but it cannot. So there are a few things we need to change. So let's make this int, since we are returning int as well. There are a few libraries we need to include, so let's include those as well. So the first two are just basic ones I include in all my C programs. I don't think both of them are needed, but it's a habit. So the third one would be random, not h, and since we are using srand and random, that would be one. And is there anything else we include? Okay, let's just leave it at that for now. So this, let's just put them as char arrays. So this basically puts it in a pointer value, and let's just leave it at int, leave this as int as well, because I'm gonna trust Git on this one. But this would be int as well, and since that isn't, let's just change this to -1 and this to -1 as well, since we saw it in the decompiler. Let's see, the password input is a 112 char array, basically a string of 112 characters, and these I believe are characters, because if we look at it in ghidra, the values that are assigned, there is a char value for each of them. So we're gonna leave it for char as of now. So byte, there is a weird thing with byte. It is not a default um, data type, so we are gonna have to define it. So let's just quickly Google byte and see byte. Basically, we're just gonna be doing this in an initial line. Instead of capital, let's just put small. Done. So it's just basically a char. So this initialization would not produce an error. The file is fine, and local int 10 is this. This is being the local int 10, which is in hex 539. If we look at it in the code browser, it is being used here as rand. So I'm gonna remove it since it's like excessive and not needed. and here we are just gonna like srand generally takes in int values. So since question marks are not allowed in passwords, like what would you call it, um, variable name, so we're just gonna remove that. And since we are compiling it and it would give out different errors it could even produce, so I am just gonna remove this and just define the one password. Instead, let's just do it where it is being declared right here. So instead of this, we can just do this. It's just an alternative way to define a char array. And a strong password. It auto corrected because I have the source file saved in the same folder, and Sublime sort of is kind enough to auto fix that. So srand is being defined here, the file is being opened, right? So param, so I have to fix the params as well. So we are gonna just do int argc, and let's just see the exact syntax to syntax command space here, that's fine. Should give us the initial this right here. Copy, let's just paste it and hope it works. It should honestly work, but you know, never know. So here it is taking the parameter, and instead of this whole thing I am just gonna put argv1, since the first one would be the program name itself and the indexing starts at 0, so we are going to take the first one, which would be the next command line argument. And scanf, so we have to replace that as well. So let's remove this, and since it's a string, so I am gonna do this. This is a way to input the string, and scanf is the program function to take the input. And here we are just gonna do password, since we changed it and everything. Password, so we are just comparing the input password taken from the user to the password. And here we are doing fseek. This is good. This is also good. Let's remove this and this. I don't think I think I renamed this. No, I didn't. That's fine. I mean, I guess I can rename it multiple use int. Multiple use int. Okay, let's just replace everything, and now it's good. The random is being called here, and I have to rename these as well because I don't like to use capital characters in variable names. And it is being XORed, and it is being printed. So I don't like this put char. Generally I just use put s, or like printf is even fine. Printf, let's remove all this and just do percent %c, so it would print one character at a time. And I think this might be good to go, so let's try to compile it. So I am gonna open up a debug session and go into solution, and let's try to compile the file. Yes. So random is not found. It may be because it's just random, not random.h. Let me just take a quick look. Okay, random is just there by default. You don't need to include that. Password 1. I see. Okay, there's a question mark there as well. Just a few errors to fix, and I copied it through. And what's the other one? 67, line 67 right here. I think I did mean password 1. Yeah, it's okay. Okay, so it is giving warning for strcmp. I think that's because like I have to include this right here, string. It's just a warning, it will still compile just fine. So now if I try base, unable to open file. So let's try fc passwd, and here let's try a random password like my name itself. Wrong password, so let's try the password we got. Strong password, and here is the encoded file. So etc, I can just show what etc passwd is. So it's just a like list of users basically present on Linux, and you know what their home directory is and what shell they, it's just a detailed thing. So I'm just using that as a base. I can also use anything I want basically. So it's just an encryption program. So if this were to be present in a CTF, it would be difficult to find out what the flag is. So here you can see a bunch of random hex values. So let's try to find out what these are. But first, let's print out. Let's not print out this, and instead print out I and the random variable we get each time. So basically I'm gonna solve this by using Python as well. So I'm using both in this example. So I'm just gonna print it in a format that would be suitable for Python solutions. So I'm just gonna print each random integer you get each time with a comma at the end. So let's compile it again and let's run it. Uh, so this is a long list. So basically we just need a first few lines of this. So a few things I'm gonna do is remove the password check. So let's just remove this and bypass this by putting it 0 and remove this. So it would automatically enter into the if condition because it would always be true. And then bytes to be encoded. So and I'm also gonna change it to a better file. So let's try and see how many lines these are. 20 lines. So I'm gonna do 30 just in case. So let's try Python. Python one liner should be enough. Print a into 30. So let's see what this does. So it's just want to print a 30 times, small a, and let's just save it to a file called temp. So now I am gonna pass in here temp, and I forgot to compile it again. So let's just compile it and pass it. Okay, so this is the first 30 random digit number it would always generate. If you want to check it, you can just run it again and again and again. It would always produce the same value. So since we have this list, let's just create a new file and call it decode.py. Okay, let's just save that and copy these variables. Okay, values. So this is going to be a list. Oh, my bad. Let's just save the whole thing first. These are the variables that I'm going to try and decode, and here I'll just put in the random variables I got by manipulating the precompiled ghidra program that I changed to perform just to print out the random variables it gets every time to XOR it. So let's try. So since like we are going to loop through this, I am gonna try and make them just like an list. So is there a fast way to do it? What I'm thinking. Hmm. I mean, okay, fine. Let's just use a regular expression here and do local, and this. This would be a to f and 1 to c. 1 to f. I don't know if it produces. Okay, so here we are just using a normal regular expression. Anything that starts with local, anything under the square brackets, it will take a range. Since we are using okay, so let's just use a to f and 0 to 9 to be more clear. Here we are just going through, like, it is present in hex, so a through f would be the alpha part of the alphanumeric in hex, and 0 to 9 is all new numbers, and here is just in the curly braces we are just defining how many number of matches for the previous one, which would be this. So let's just do a space equals to and then do a match. So dot 3, I think it is 4, it is 4. So I'm putting this in parentheses because I need these to be used in the next line. Basically I'm just gonna replace it with match, which should be the first match. $1 represents the first match, which would be present here, anything that comes under the parentheses, and then just put in a comma. Let's try this. Okay, it worked quite well, but I can do better, so let's just do n. So h. Okay, fine, I have to rewrite it again. 0 to 9 and A to F. 2 and this, and here the dot represents like any character at all, any match, any non-empty character it would take. And here let's just try 4. Okay, and this, and now if I press replace all, and I should have done that, replace all. Okay, replace all, and here it is just one perfect line. There are few edits to be made here, and these are encoded. Yes, it's sort of weird reading it like this, so I'm just gonna turn off auto wrap, and for char in encoded chars, print encoded char. So we're just gonna print the XOR. I think I should explain the XOR a little bit. So XOR, what it does is, like, let's explain it here. Python. So if I, like, 3 is like 2 binaries and what, like 2 ones and nothing else in binary format, and if I XOR it with 1, it will always give 2, because it flips the, if the, okay, let's try and explain it here. So let's say this is 3 and this is 1. 3 and 1. What it does is it flips the last one. This is the biggest value of 1 present, so after this it doesn't take anything. So basically it does this, and then it flips the non-matching values. It basically flips everything, I think. So 0 and 1 becomes 1 and this becomes 0. So in this binary it's 2, and here we can see the value is 2 as well. So if I XOR the same thing with 2, it would give 1. So if we have, it's basically like a arithmetic problem, like 2 plus 5 is equals to 7. So if we have like 2 of these value, we can find out the third. But instead of like it becoming 2 plus 2, let's say, yeah, so 7 minus 5 is equals to 2. Instead of it becoming like this, it just stays the same, the operator does not change. So I can just XOR it and XOR it to the random value. Random, since we are taking like the same what would you call it, the same index from both lists, I'm just gonna put it in I and just do encoded chars. This would like basically get the first value, second value, and so on till the entire list is finished. So let's try and run this with Python. List cannot be, oh right, so I have to put it in length as well. since range only takes in integers. Okay, so it is giving us some int values. So what we need is char. So let's try and turn it into a char. Hmm. It the first three letters are FLG. So I think we may have succeeded. So let's try removing these end line wraps. So we can just get it on one line and put this here to be pretty. And here we have it. The flag is here. And there's nothing. Now let's just go over the code. The code that made the binary. So here the encrypted flag is in the form of ints, which the compiler takes it and turns it into hexes and then saves it into individual variables in a sequence. Sorry. So that's like just like the compiler thing. It's basically an array here. srand is just a random key. It would be optimal to like put it in a ever changing variable like time or something like that. And here we have like passwords. We have two strings. This is which we use to take for input, and this is the actual password. As you can see here, it's strong password, and here if the file is null, it is printing unable to open file and returning -1, which represents a false run, like the program didn't succeed. Here the L doesn't really play any role at all. It's just like something like a standard to be followed, I guess. So secant here would be 2. I just used it from the stdlib. It is defined there. So here it would be 2 to seek the end of the file, and then file size is saved here. And in each loop, it is XORing it with the key. Key is a randomly generated one, but since the srand which is defined is based on a constant, we did predict this here and print out the random values here. Since as you can see, the decompiler puts in a lot of extra stuff which is not needed. It's a small, very clean program, but the compiler sort of makes it complicated. So do not get intimidated if don't learn it quite as good. I would suggest though that you learn programming first. Since I'm a developer myself, I do recommend that. But sorry, I got distracted. Since I'm a developer, I would suggest that to learn programming first. But I do know people who have learned it like hacking first, programming later. This is a good challenge for like very easy based CTFs. So the next, so I do have a actual CTF program here, like a binary. It's UD. So I think I am gonna introduce GDB here as well. So GDB is a GNOME based debugger. So I am just gonna put in UD and disassemble is a disassemble disassemble main. Since this was also not stripped, main would still exist. As you can see here, UD2 and like there is a ZOR here as well. But there are a bunch of UD2s, and if you Google around a bit, UD2 is not a assembly code like a instruction. So it would, like, if you try to run this, it would hang and give out segmentation fault or something of the sort. So let's try running ud and just give any password. It just doesn't return anything. So if let's try strings is a program that would help you like print all of the printable characters from a binary. So let's try getting this, and less is just a better way to view it. So initially you just see the libraries that are being used, and here are the functions that are being imported and used, and here is the functions that are like present but not like these are the strings present in the program but not by default. These are the custom things. Since we saw here challenge password, it should be defined in main, and these are just a bunch of like memset and data stuff which are present in basically all binaries. So here you can see FLG is printing out a string here in between, but the string is missing, so we cannot view it from strings. So let's try opening it in ghidra as well. Close this, save. Let's import a new one, ud. Okay. Yeah. Okay. So it's imported, and let's look at this. It's a extremely small one, and it is giving a invalid instruction exception for a while. Do while is a loop which would do it again and again, but it is basically still doing it. So it is giving out invalid instructions, so the program would crash every time. So let's try it to open it in a hex editor. Hexer is a good one that is very similar to Vim. In terminal based editors, I do like to use Vim a lot. It's quite good and present in most Unix system as well. So since it is Vim based, key instructions and all, I like to use this. Here is the first few lines are the headers, which would define it as an elf binary. Here you can see like right here you can see the libraries it would use. So let's just keep going down. These are the libraries and the functions it imports from different libraries. These are just random null bytes for a while. And here is the string present in the binary. As you can see here, the first one is the like the error messages. It shows if you don't have enough arguments. But here, right here, as you can see, it is printing the flag for the like CTF, but it is not like you cannot see the string here itself. So when you see it here, it's like if you include these few lines, you can say that it's just it's initialized before itself, before the flag printing itself. So I don't okay, let's try and match it here. So this would be the underscore, and this right here 00 is a null byte. Null bytes are used, as I said, to terminate strings in binaries. So this is basically saved in like three to four different string variables. So this is the first one, meaning I, T, Z, then the null byte where the string is terminated, then it is underscore O, I'm sorry, 0, N, then another null byte, then the string is terminated there. So let's just write it down real quick. So FLG, and this is the format. Okay, let's just quit this and open it again. I'm sorry, it wasn't working for me, the up and down arrows. Okay, so let's just type it out. So ID Z, then the null byte, then there's the underscore 0, and then there's the null byte, and then there is ly, then there's the underscore, then again the null byte ud, and then there's the 2, and again the null byte. And since FLG, this whole thing doesn't have a null byte, the next string I'm gonna ignore, because if it has the FLG. So basically this is the flag itself, and here ud2 means undefined instructions. So I think that's gonna be it for today. Yeah, that's it. If anyone did watch, thank you, and I'll try to make it better next time. I think I'm gonna do like CV stuff next time based on binaries. I think I'm gonna get into like binary based CVs and try to explain them. That's all for today.